Hello, welcome to the fourth lecture of the seventh chapter in Mathematics Class 11. So we are dealing with binomial theorem, and till now we saw how we can expand, bracketed terms for different kind of index like powers. So we first saw how we can do it manually using products between the two bracketed terms or the bracketed term that we are trying to evaluate. And then we saw that there were easier methods to solve these using Pascal's triangle. And even after using the Pascal's triangle, we do face quite a bit of issues to expand. And then we came to the concept of using combinations to find the coefficients of the terms of the expansion. So we saw till the last time how it is easier for us if we calculate the coefficients, and we saw that there are a few rules which are followed while calculating the coefficients and the number of terms that we are supposed to get, and also the powers that we will derive in the expanded form when we are expanding for the power that we are dealing with. So we will today start with doing some examples. We'll see to how we can solve different kinds of examples or different kinds of questions using the entire concept of combinations for now. So the first question, as even like when we had started binomial theorem, the chapter, we had seen that for say if we are asked to evaluate numbers like this 101 raised to say 5, or 98 raised to 6, or your 104 raised to 4. Okay, so these kind of evaluations is very difficult because obviously the number itself is very, very high. And even if you, write it in terms of this kind of, expression, it will still be difficult if we do, the general way that we can do 100 plus 1 in bracket multiplied to itself 5 times. So we then obviously we came to the coefficient concept. So let's try to solve using the coefficients and see if it is easier for us in that sense. So suppose you are asked to find or you are asked to evaluate this. Okay. So you can write this in terms of 100 minus 1 raised to 5. Okay, so over here, our n is equals to 5. Okay, so the index over here is 5. So, or you will have the number of terms. Okay, so t is your number of terms. So t will be 6. Okay, so 6 terms we will have in the expanded form. And as you know, we have a, x, and b, y for every term. So your x will start from 5 and go all the way up to 0, and your y will start with 0 and go up to 5. Okay, so these are the rules that we will be seeing, that we will be following. So if you write this 100 minus 1 raised to the whole raised to 5. Okay, and then you write the first, let's write the general form of this thing. So our coefficients, okay, so our coefficients are going to be 5, C0, 100 raised to 5. Okay, so your A is 100 and B is 1. Okay, and since the first term, your B is equals to 0, so it will be 1, so we don't write it. Now, since we have a negative sign, so whenever we expand, the alternate signs are going to change. Okay, so alternate signs will be negative. So since the first term has your positive sign, the second term will have a negative sign. Okay, so the first term is positive, the second term is negative. So then you have 5C1. Okay, so your coefficients, the combination, okay, your combination is usually going to be written as NCR, which is N factorial, R factorial, N minus R factorial. Okay, so this R will, in this case, okay, so in this question's case, okay, R will start from 0 and go all the way up to 5. Okay, so the first term we have put 5C0, the second one will be 5C1. Then, as you know, that X has started AX, okay, A raised to X. So it has started with 5, it will go on decreasing by 1. So your 100 is then raised to 4, and 1 you will just you can just write 1 because 1 raised to 1 this would be. Then you have 5C2 100 cube 1 square, so you write it right now. Okay, then obviously again over here this will become negative. Okay, your fourth term becomes negative 5C3. Now you will have 100 raised to 2 and then 3. Then you have plus 5C4. Okay, then you have 100. So this will be 4. Yeah. And then the last one, 5C5. And 100 would be raised to 0. So that is 1. So 1 raised to 5. Okay. So now to calculate the coefficients, okay, that we have. Now 5C0 is going to be 1. So this is going to be just 100 raised to 5. Then minus 5C1. Okay, so if you write it 5 factorial, or maybe we'll just calculate the coefficients first, so then we can easily, write for the coefficient. So let's 5C0 will become just 1. So then you have 5C1, so that would be 5 factorial upon 1 factorial, that is R factorial, and 5 minus 1 factorial, so that is 4. So you know that any factorial you can write as n into n minus 1 into n minus 2, okay, all the way up to 1. Okay, so this is how you write the factorial. So 5 factorial can be written as 5 into 4 into 3 into 2. So let's just write this as 4 factorial, 1 factorial and 4 factorial. So 4 gets cancelled. So this is 5. Similarly, your 5C2 would be 5 factorial upon, you first write 2 factorial, and then you write 5 minus 2, 3 factorial. Similarly, you can, write this as 5 into 4 into 3 factorial. Okay, and 2 factorial would be 2 because it's 2 into 1. And then 3 factorial you write, you cancel it out to 10. And then you have 5C3. 5C3 can be written as 5 factorial. And so 5 minus 3 is 2 factorial. So now you can see that this is actually equal to your 5C2 itself. So you can write this as 5C2. So that is going to be 10 again. And then the last one is 5C4. So when you write it in the factorial form, it's 5 factorial, 4 factorial, 5 minus 4, 1 factorial, which is again equal to your form of 5C1. Okay, and that is going to be 5 again. So this is what we get. So rewriting it, okay, rewriting all the coefficients now. So the first one would be 1 because anything, when your r is equal to 0 is 1, and when n and are equal at that time also, it is 1. So this will be 100 raised to 5 minus the first coefficient, or sorry, the second term's coefficient is 5. We have 5 and 100 raised to 4. Okay, and the rest of the b part is going to be 1, so we are not going to rewrite it anymore. Then the next coefficient was into 3. Okay, and then minus again, and 10, 100 raised 100 squared. Okay, and then plus again, and 5 into 100, and the last one will be minus 1. Okay, now let's expand, or write the entire thing. This will be 5, and 5 into 100 raised to 4, so that would be okay. And then you have 10 multiplied by your 100 cube, so you just add the zeros for the 100 cube over there. Then you have 10 into 100 squared, so you write 10, and then you square your 100 and write the zeros. Okay, and then you have plus 500 minus 1. So if you calculate this, either manually or, via calculator, what is the final answer that you get is 950990499. Okay, so this is the answer that you get when you use the concept of combination to find the or evaluate such expressions. Actually, this would then be written as, this is 99 raised to 5. Okay, so this is actually the value of 99 raised to 5. So this is how we solve such expressions. Now let's take another example. So suppose your question is solve for okay. So suppose you are given in this form. Okay, so we have to find the answer for this expression. So first, let's expand each of the bracketed terms first. So first you have a plus b raised to 5. Okay, so now we'll write with respect to all the coefficients also. So the first term would be 5c0 a raised to 5 plus 5c1 a raised to 4 b raised to 1 plus 5c2 a cube b squared plus 5c3 a raised to 2 b cube plus 5c2. So you have a and b raised to 4. And the last one, 5c5 b raised to 5. Okay, so this is your expansion for a plus b the whole raised to 5. Now let's find a minus b the whole raised to 5. Okay, so now over here only the sign changes. All the terms are going to be the same. So first let's just write all the terms. Okay, 5c1 a raised to 4b1, 5c2 a cube b squared, 5c3 a squared b cube, 5c 5c2 a b raised to 4, and then 5c5 b raised to 5. Okay, now just change the signs of the alternate terms. Okay, for a minus b the whole raised to 5. So this is what we get. Now we have to get a plus b raised to 5 plus a minus b the whole raised to 5. Okay, so if you kind of add up all the individual terms of this of these two expansions, what you are remaining with. Okay, so you have the first term for both of them will be added up. We have 2 into 5c0 a raised to 5. The second term would get cancelled because of plus minus. And then again the third term, so 2 twice into 5c2a cube b squared. Again, your fourth term would get cancelled because you have opposite signs, and then you come to your fifth term. So again, this would get added up. 5c2ab raised to 4, and the last term again gets cancelled. Okay, so this is what we get. Now, if you quickly, if you remember your 5c 0 would be 1, 5c 2 is actually your 10. Okay, the coefficient is 10. Then your the last one, I think it should be 4. Yeah, something like that. So the last one is, yeah, 5c4 is actually is equal to 5. Okay, so you can solve these with the factorial also if you are not sure. So now you just write the coefficients. So 2, so this is 1, so this would be actually 2 a raised to 5. Now this would be 5, C2 is actually 10, so this becomes 20 a cube b square. And the last one is 5c4 is 5, so 2 into 5, so that's 10 a b raised to 4. Okay, now you take out say 2 a b squared. Okay, suppose you take it out just to simplify it. Okay, so then what you're left with is a raised to 4 plus 10a squared plus 5b squared. Okay, so this is the answer for a plus b the whole raised to 5 plus a minus b the whole raised to 5. Okay, now suppose you are given, say, your a is, say, root 3 and b is equals to omega, sorry, I'll put it in the next slide. Yeah. So the answer that we got, okay, so a plus b raised to 5 plus a minus b the whole raised to 5 is 2ab squared a raised to 4 plus 10a squared plus 5b squared. Okay. So let a is equals to root 3 and b equal to root 2. Okay, so you input the values for a and b in this expression. So what you get is 2ab squared a raised to 4 plus 10a squared plus 5b squared then becomes 2 into root 3 into root 2 the whole root 2 square. And now in bracket you have a raised to 4. So that is root 3 raised to 4 plus 10 into a squared again. So root 3 squared. And then you have plus 5b squared. Okay, so root 2 squared. So this is what we get. So now root 2 squared is actually 2 itself. Okay, because root 2 into root 2 is equals to 2. So 2 into 2, 4. So this is 4 root 3. Okay, and now in the brackets, you have root 3 raised to 4. Okay, so root 3 into root 3 is 3. So you get 3 into 3 then when you put root 3 raised to 4. So this is 9. And then you have 10 into 3 because root 3 into root 3 is 3. So this is 30. Okay, and then the last one is root 2 squared. So that is 2. So 5 into 2, 10. Okay. Now you multiply 4 root 3 by all the terms inside. So what you get is 36 root 3 plus 120 root 3 plus 40 root 3. Okay, so all these terms have root 3, so you can add the part that is outside the root. So what you get is 160, 160, 196 root 3. Okay, so this is your final answer. If suppose you are given the values for A and okay, so when you're solving such questions, excuse me. Okay. Now let's take another example. Suppose you are given evaluate x plus 2 raised to 4 plus 2 raised to 4 plus x minus 2 raised to 4 when x is equals to root 3. Okay, so before substituting for root 3 in the in the expression itself, let us first simplify it and get it down to just in the form of simplified equation with the variable x. So you take x plus 2 raised the whole raised to 4 and then you expand it. Okay, so you have again plus 4c1 x raised to 3 2 raised to 1 plus 4 c2 x squared to squared plus 4 c3 is x into q plus 4 c4 2 raised to 4. Okay. So this is the expansion. Then for x minus 2, the whole raised to 4, you have 4 c0 x raised to 4 to 0. Then you have minus because we have minus sign. So all the alternate terms would have a negative sign. So you have 4 c1 x cubed 2 raised to 1. Okay, so the terms will be the same, only the sign will change in the alternate fashion. So you have 4c2 x squared 2 squared minus 4c3 x to cube plus 4c4 and you have 2 raised to 4. Okay, so over here you can see that this term and this term cancels out, while this term and this term cancels out. So therefore, x plus 2, the whole raised to 4 plus x minus 2, the whole raised to 4 can be written as, okay, so there are two terms of this. So 2 into 4c0 x raised to 4, 2 raised to 0 would become 1. So leave it at that. Then you have the third term. So that is 2 into 4c2 x squared into 4. And then the last term. So 2 into 4c4, 2 raised to 4 becomes 16. Okay. Now you solve this further. So your 4c0 is going to be 1. So this is 2 x raised to 4. Then plus now 4c2. Okay, so sorry. If you calculate 4c2, you get 4 factorial upon 2 factorial, 2 factorial. Okay, so this will become 4 into 3. If you cancel out 2 factorial and 2 factorial, 2, 2. So this is 6. Okay, so this is 6. You can directly multiply 6 with 4. So that will, okay, so 6 into 2. Okay, this is 6 into 2 is 12. Please get a minute. Yeah, so you have 8 into 6. So that is 48 x squared. Okay, and then the last one, 4c4 is 1. So 16 into 2, so you have 32 there is no x term anymore, okay, in the last term. So this is what you get. So if you take out, okay, so this is what you get. So if you take 2 and 2 out, so this would be x raised to 4 plus 24 x squared plus 16. Okay, so this is what you get. Now we are saying what would be the what would be the value? Okay, if you what would be the value if your x is then taken as root 3? So okay, so when x is equals to root 3, this would be then x plus 2 raised to 4 plus x minus 2 the whole raised to 4 would be 2 into uh, root 3 raised to 4 plus 24 into root 3 squared plus 16. Okay, so this is 2 into 9 plus 24 into 3. Okay, so 24 into 3 is 12 and 72 and plus 16. So what you get over here is 2 into 6, 8, 8, 7, 17, 1, 97. Okay, so the final answer that you get is 194. Okay, so this is your final answer. So this is how you can evaluate, such kind of expressions. Let's take another example. Suppose you are given evaluate 4 plus 3 raised to 6 minus 3 4 minus 3 raised to 6. Suppose you are asked to evaluate this. So let us first expand root 2 plus 3 the whole raised to 6. Okay, so this becomes 6 3 0 root 2 6. Then plus 6 3 1 root 2 raised to 5 multiplied by 3 plus 6 3 2 root 2 raised to 4 3 raised 3 squared. Okay, then you have 4 6 3 3 root 2 raised to 3 multiplied by 3 cube again. Okay, and then you have plus 6 4 64 root 2 raised to 2, and then you have 3 raised to 4. Okay, and then you have 65 root 2 and 3 by 3 raised to 5. And then, oh sorry, I forgot to change the sign. Actually, no, this is addition itself, sorry. So the next one is 6C6, 6C6, and this is 3 raised to 6. Okay, so root 2 is raised to 0 over here, so it is 1. So now for the root 2 minus 3, the whole raised to 6. Copy down all the terms first, and then we will change the signs. So we have 6C2 root 2 4 3 squared, and then we have 6C3 root 2 cube 3 cube, and then we have 6C4 root 2 squared 3 raised to 4, and then we have 65 root 2 3 raised to 5, and then we have 6 3 raised to 6. Okay, so let's change the alternate sign. Okay, so this is what we get. Now we have minus, or we are subtracting both these expanded terms. So the signs will change, okay, when you expand it. So what you are actually left with will be, you will have the first term goes away, the second term will remain. So that is 6c1 root 2 root 2 5. Okay, and it will actually become 2 into. Okay, so 2 into that. This term will stay. Okay, because the negative sign over here then becomes positive, so you can add this term and this term. So similarly, the third terms would get cancelled out. Then you write the fourth term. Okay, so that would be plus twice 63 root 2 cube 3 cube. Okay, then the next one again gets cancelled because this will become negative and this is positive, so this will get cancelled. Then you write the next term 65 root 2 3 raised to 5, and the last term again gets cancelled. Okay, so this is what you can find. So quickly just calculate or see what these coefficients are. 6c1 will be 1, 6c3 will be 6 factorial, 3 factorial, and 6 minus 3, 3 factorial. So this would be 6 into 5 into 4 into 3 factorial. And then you have, you expand 1 factorial and keep the other, so 3, 3. So this is 20. Okay. So that is the factorial, and the other one that we need is 6c5. Okay, so this will be 6 factorial upon 5 factorial and 1 factorial. So 5 factorial will get cancelled if you write 6 into 5 factorial. So what you are remaining with is 6. Okay, so 6c1 is 1. So this is 2 into root 2 by root 2 raised to 5 would actually be 4 root 2. Okay. So then this is 2 into 6c3 is 20. So you can just write this as 40, and root 2 cubed would be 2 root 2 and multiplied by 27 over here. Okay, 3 cube. And the 6c5 is 6. Okay, so you have 6 root 2 multiplied by so your 3 raised to 5 is so you have 3 raised to 5, so that is 243. Okay, so this is what we get. Now if you multiply, so 8 root 2 plus this would be 27 multiplied by 40 multiplied by 2. So this is 2160 root 2. And this one would be 243 multiplied by 6. So that is 8, 825. Okay, so 1458 root 2. Okay, so root 2 is common everywhere. So you just write root 2 and then you add all the numbers that are prefixed to the root 2. So that is 8 plus 2160 plus 1458. Okay, so that is 3626 root 2. Okay, so this is what we get. So as the evaluated result of root 2 plus 3 the whole raised to 6 minus root 2 minus 3 the whole raised to 6. Okay. So this is how you can solve such sums. Now, obviously, we are expanding the entire, binomial expansion part. Okay, so we are seeing, to understand each term or which term comes when we do the entire expansion. But suppose sometimes, we are only concerned with one particular term, say maybe the third term or the fifth term or the sixth term, say when your power of index is, say, 9. Okay, so then it becomes difficult. So, for example, if you have, a plus b whole raised to 4. Okay, so we do not want to expand this entire thing, but okay, so suppose you are given a plus b the whole raised to 4. Okay, and we wish to find the coefficient of the term containing a q. Okay, so we know that if we expand a plus b the whole raised to 4, we will get a term where we will have a cube, okay, as a part of that term. But we want to find what will be the coefficient. So the coefficient would be the coefficient that is respective to the expansion or to the n power expansion, and also the b term. Okay, but how do you do this, okay, without doing the entire expansion? So some things that we remember, that the number of terms, okay, so over here your n, okay, so since we have a plus b raised to n, okay, this is what we know. So therefore your n over here is going to be 4. If your n is 4, your number of terms for the expansion is going to be n plus 1, that will be 5. Okay, so you will have 5 terms. So you will have T1, T2, T3. So if you like put the addition sign, T4 plus T4 plus T5. Okay, so this is what you see. So suppose like you converge it to Ti. Okay, so your I goes from 1 to all the way up to your n. Okay, whatever your n is. This is your general kind of, this is your general understanding of it. So over here, since our, n is 5, so this is what we have. So we want to find the term. Okay, so the coefficient of the term which has your a cube. But how do we get the a cube? Okay, so what is the relation? We know that all the coefficients are in the form of NCR. Okay, so where your n remains, okay, so your n and your r starts from 0, 1, 2, all the way up to n. Okay, and similarly, when you have a raised to x, okay, so x will be going from n and decreasing all the way up to 0. And when you have by, okay, so for your y will start from 0 and go all the way up to n. Okay, so these are the general kind of rules and the patterns that is followed by the expansion. Now, as per this expansion, say T1, okay, we consider, let's take the first term. Okay, so T1, we know that it would be written as for this expansion, okay, a plus b the whole raised to 4. Okay, so for this, your T1 would be 4C0 A raised to 4 and B raised to 0. Now, when you take this, okay, and you compare all these kind of, variables that we have, kind of explained over here. So over here, you can see your NCR. Okay, in the NCR form, your N is equals to 4. R over here for this term, your R is equals to 0. Okay, your Y, B raised to Y. Okay, so Y is equals to Y is equals to R is equals to 0. Okay, over here, if you take this TI, okay, so for TI, okay, so for TI, your I is actually is equals to R plus 1. Okay, so you have 0 plus 1, so that would be 1. Okay, and your X is equals to N over here. That you can also write as N minus R. Okay, so that is N minus 0 for the first term. So if you compare this and with all of these, you can write a general kind of explanation of any of the terms of the expansion. How do you write is that your i's r plus 1. Okay, so your r plus 1 term is going to be, say over here you have n. Okay, r is equals to 0, so just like r, you have a. Over here we are taking a raised to x. Okay, so for a raised to x, the x part you can write as n minus 0 or n minus r. Over here, since r is, since r is equals to 0, so your first term, okay, because we have r is equals to 0, your first term is 0 plus 1 over here. So NCR a raised to n minus r. Okay, so if you do 4 minus 0, it will be 4 only. Okay, so it's the same, kind of similarity over here. And your B would be raised to r. Okay, because over here we have 0. Okay, so this is your, kind of the general way of writing any term for expansion. So if you want to write for, say, T2, okay, now you know this I, when you have I is equals to 2 and I is also equals to R plus 1. Okay, so therefore, what is your R? R is equals to 2 minus 1, so this is 1. So your T2 will actually be your NCR. So N is 4. C is equals to, over here you have R. So R is 1. Okay. A raised to N minus R. So N minus R is 4 minus R. R is 1 for the second term. Okay. And B raised to R. Okay. So this is how you can then find each term, any term when you are given. Okay. So when over here, now we want to find what term will have a cube in it. Okay, what term will have a cube in it? Okay, so over here we are going to, see that ax is in the form of a raised to 3. Okay, and our given expansion is a plus b raised to 4. Okay, now we remember, okay, that a will always be written in the form of a raised to n minus r. Okay, so therefore we can write that 3 is equals to n minus r. We want to find what r, which r this is, which r. Okay, because if we find the r, we know which term we have to generate. So over here n is equals to 4. Okay, so 3 is equals to 4 minus r, and therefore your r is actually is equals to 1. Okay, so if r is equals to 1, so the concerned term, okay, that we are going to see is going to be your second term. Okay, so if r is equals to 1, we want to calculate r plus 1, that is T2. Okay, now for the term 2, now if you put, your other kind of, substitute all the other values, like your NCR is actually 4C1. Okay, R is equals to 1. Okay, remember this. So you have 4C1. And obviously A, when you have, 4 minus R, okay, so A 4 minus 1, and your B will be raised to your whatever R there is. Okay, so B raised to 1. So what you get is 4C1. Okay, so if you get this, so you have 4 factorial upon 1 factorial and 4 minus 1, so that is 3 factorial. Okay, and A cube B1. So this actually will give you 4 factorial, so 3 factorial can get cancelled. So 4A cube B. Okay, so the coefficient of A cubed would be 4B. Okay, so therefore 4B is the coefficient of the term, okay, of A cubed in A plus B the whole raised to 4 expansion. Okay, so you can see that it is very easy to, find the any term or the coefficient of a particular term that we want to find, okay, by just using the formula that TR plus 1 is equals to NCR A N minus R and B raised to R. Okay, so this is something that we can use. So let's solve another question related to this. Okay, say your question is find the coefficient of x raised to 4 in x plus 3 raised to 9. Okay, so now over here we can see that n is equals to 9. And your x is actually your a. Okay, a plus b, if you correlated a plus b form, so your a is x raised to 4. Okay, so you have to find x raised to 4. So that would be, since this is the in the a, okay, so this is in the place of a, you can write this that x is equals to 4 can also be written in terms of n minus r. So that is x 9 minus r. Okay, so therefore 4 is equals to 9 minus r, and therefore your r is going to be equal to 9 minus 4, so that is 5. Okay, so our r is going to be 5. So when we have r, so the term that we want to find is tr plus 1. Okay, so this is actually going to be your T6, and that would be your NCR. So your N is 9, C, and your R is 5. A, okay, so A, so let's just write X directly over here. So you have X raised to N minus R, so that is 9 minus 5 over here. And in B, in place of B, you have 3, and 3 will be raised to your R value. So this is R is equals to 5 over here. So 3 raised to 5. Okay, so now let's just get the coefficient. So you have 9 factorial, 9 factorial upon 5 factorial upon 4 factorial. Okay, so 9 minus 5. So you have x raised to 4, and you have 3 raised to 5, so that is 243. Okay, so this becomes 9 into 8 into 7 into 6 into 5 factorial. Okay, so you can cancel out your 5 factorial, and 4 into 3 into 2. 1 is your 4 factorial, so 5 gets cancelled. 4, 2, 3 into 2, and 6. So what you are left with is 9 into 2. Oh, sorry. You multiply this part with x raised to 4 and multiply the 243. So if you multiply 9, 2, 7 and 243, what you get is 30618 x raised to 4. So this is your coefficient. Okay. So your coefficient, we are only finding the coefficient. We are asked to find the coefficient, the value of the coefficient of the term with x raised to 4 in it. Okay, so coefficient of x raised to 4 term is 30618. Okay, so this is how you can find the coefficient. Now let's try to see if we can find different kind of terms. Okay, so different terms. So I think I need to add a slide. Okay, so suppose the question that you are given is find the third and fifth term of x plus root 2 root 2 root 2 raised to 8. Okay, so over here your n is going to be 8 and we want to find T3 and T5. Okay, so T3 would be, okay, so this we want to get it as R plus 1. Okay, so for when your T is equals to 3, okay, R then becomes 3 minus 1, so R is 2. Okay, so you can write T3 in the form of where your R is equals to 2 is NCR, then becomes your N is 8. So 8C, R is 2. Okay, and then A raised to N minus R, so 8 minus 2, and your B. Okay, so in place of A, we'll write B X. Okay, so X, and your B is root 2, and root 2 would be raised to R, so over here that is 2. Okay, so this you will get it as 8 factorial upon 2 factorial, R factorial, and N minus R is 6 factorial multiplied by X raised to 6, and you will have 2 over here, okay, multiplied by 2. So if you expand 8 factorial, so 8 into 7 into 6 factorial, 6 factorial, 6 factorial gets cancelled, and 2 factorial is 2. So 2, you can divide 8 by 2, so that is 4. So 4, sorry, yeah. So 4 into 2 into 7, so that is 8 into 7, you will get this as 56 x raised to 6. Okay, so this is your third term. Okay, with your R is equals to 2. Now for T5, if you write it in the form of R plus 1, so your R is going to be, okay, so your R is going to be 5 minus 1, so that is 4. Okay, so therefore your T5 would be NCR. Okay, so your N is 8 and R is 4 over here. And then you write this as X, N minus R. So you have 8 minus 4. And B, so B raised to R. So you have 4 over here. And then what you get is 8 factorial upon 4 factorial, 4 factorial. Okay, X raised to 4 and root 2 raised to 4. This would be, if you expand and get 4 factorial out, and what you are left with is 8 into 7 into 6 into 5 upon expand 4 factorial. Okay, so this 2, okay, multiplied by x raised to 4, and root 2 raised to 4 is actually 4 itself. Okay, so this you get as 7 into 8 into 7 into 40. You get this as 280 x raised to 4. Okay, so this is your fifth term. Okay, so this is very easy. If you remember, like even if you do not know the general, kind of the term, okay, how you find T R plus 1, we will also see later on, there are proofs related to this and there are more easier way to find terms. Okay, so even if you don't remember this, this general form, you can still get different kind of terms if you remember the rules. Okay, so the rules is that the number of terms that you have, and also the way your x powers of a and b, how they will vary. Okay, and that the sum of the powers of a and b should be equal to your power of index that you are calculating for. Okay, so this those rules are always going to be very important. The pattern that the binomial expansions follow is very important for you to remember. Okay, so we will end the class over here. So we have solved quite a few examples today, based on the different kind of uh, different ways of using the concept of combination. So in the next class, we will do the proof of the binomial theorem also, and we'll move forward with that. So thank you so much for attending this class.